So an important property of potential differences is that they do not depend on the path that you take to calculate the potential difference. So let's say I want to find delta V, which is V final minus V initial. Now, say I have here, what I have is in this area, I have a uniform electric field, meaning a constant, same direction, same magnitude everywhere. But here the electric field does weird things. It points in all sorts of directions and it has different magnitudes, not uniform, and that is not great. Now, if I have, let's say the final point is here, but if the path that somebody chooses for us to find the potential difference does something like this, okay, let's say they say I want you to find the potential difference, and the path, one of the paths that you can take to do this calculation is to go from here and go through this weird electric field pattern and then arrive at your final point. Well, you know, I may not do that. I may not use this path to do the calculation for the potential difference, because I know that I can calculate the potential difference with any path I want. And really, since the electric field is uniform here, I'm gonna make my life easier. And I'm gonna say, you know what, I'm gonna go from the initial to the final point, and I'm gonna move on a straight line, and I will never go out from the area where the electric field is uniform. So I am moving in a uniform electric field, same magnitude, same direction. My calculation is gonna be much easier if I follow this path, my straight line, let's say. Now, at the end of the day, as I said, whether you calculate, let's call this path 1, let's call this path 2. At the end of the day, when you find V final minus V initial, if you do the calculations from path 2 and you do the calculations from path 1, you will end up finding exactly the same thing. And that is because the potential difference does not depend on the path. So when you have to calculate the potential difference, choose the one that makes your life the easiest.